This course module will familiarize you with the Profibus physics. After completing this module, you will be able to name details of the Profibus DP and PA topology, physics. Name the number of bus participants and addresses. Know the transmission rate and cable length. Name details of the bus topology in hazardous areas. Know the FISCO model. When engineering a Profibus network, it's important to take into account the Profibus rules and limits as early in the design phase as possible. Proceed in a step-by-step manner, as described in the following. First of all, define the number of bus subscribers or addresses per Profibus line. Every bus line is subdivided into segments. Every segment must be terminated with a resistor at its start and end. A maximum of 32 bus subscribers or addresses respectively can be connected to each segment. If the maximum number of field devices should be insufficient, a Profibus DP segment can be enhanced with another segment when inserting a repeater. Again, the same rules are valid. 2 termination resistors are required, and the maximum number of bus subscribers is 32. For setting up a Profibus PA segment, a Profibus DP PA segment coupler or link is required. The rules regarding the termination resistors and the maximum number of 32 subscribers also apply to the PA segment. All segments together must not exceed a maximum of 126 bus subscribers per Profibus line, with addresses 0 to 125. Should this be insufficient, another Profibus line can be connected to another Profibus MasterCard, and so on. Solely, the performance of the distributed control system may limit the possible number of Profibus subscribers in a plant. In the next step, you define the Profibus cable lengths as a function of the transmission rates. First, we consider the Profibus DP. 10 DP transmission rates can be configured in the Profibus MasterCard. Transmission rates from 9.6 kilobit per second to 12 megabit per second are possible. The higher the transmission rate, the faster the device data or measured values are transmitted. For copper cables, this setting has a direct impact on the DP cable length per segment. The higher the transmission rate, the shorter the maximum segment cable length, which may vary between 100 and 1,200 meters. The process industry typically uses transmission rates of 500 or 1,500 kilobit per second in order to obtain the optimum compromise between the cable length and transmission rate. Should the DP cable length be insufficient, you can, of course, enhance the Profibus DP line by a repeater. Using a fiber optic DP segment will significantly extend the DP line. Let us now consider the Profibus PA, the transmission rate of which is always fixed to 31.25 kilobit per second. As a result, the maximum length of a PA copper cable segment is limited to 1,900 meters in any case. When using an intrinsically safe Profibus PA in a hazardous area, the maximum permissible cable length is even 1,000 meters. Note that the trunk and all spurs must be added. At first sight, defining the PA cable length seems to be quite easy. But it must be taken into account that all PA field devices have to be powered via the PA copper cable. Consequently, a voltage drop occurs in the cable, which can be calculated with the formula U equals R times I. As a result, the maximum possible PA segment length is noticeably reduced by the number of PA field devices, the voltage drop in the cable, the power supply limitations, and the copper cable diameter. This must always be calculated explicitly in the design phase in order to prevent nasty surprises in the commissioning phase. A Profibus PA segment is built up using T-junctions. This means a PA segment consists of a trunk and 1 to a maximum of 31 spurs. The spur lengths are subject to rules. The more spurs, corresponding to PA field devices, are used per PA segment, the shorter each spur is. As a result, a spur can have a length between 120 meters and 1 meter. Only one field device should be connected to each PA spur. When setting up the intrinsically safe Profibus PA segment in the hazardous area, a maximum length of 60 meters and up to 8 spurs, corresponding to 8 field devices, are permissible, according to the FISCO model and with passive T-junctions. When using field bus barriers instead of passive T-junctions in the hazardous area, greater lengths are possible. According to FISCO, 2 different Profibus PA topologies are basically permissible in hazardous areas. A topology with passive X-way junctions allows for a maximum number of 8 PA devices per PA segment, and a maximum segment cable length of 1,000 meters. When using active X-way junctions, for example field bus barriers, more devices, up to 16 per PA segment, can be connected, and the maximum possible segment cable length is increased to 1,900 meters. The reason is that the field bus barriers can be supplied with more power via an XE connection. The FISCO Field Bus Intrinsically Safe Concept model allows you to easily and quickly design and use a Profibus PA system in the hazardous area. On the user side, only some few requirements must be met or checks performed. Have the active PA devices been certified according to FISCO? Just ask your device vendor for the certificate. Do the values for UI, II, and PI comply with IEC 6007911? Just look this up in the device certificate. Are the cable parameters observed? Quite easy if the type A Profibus cable is always used. Are the line terminations correct? Easy, as the Profibus must always be terminated. Is the maximum cable length, trunk and spurs, always observed? Simply measure the cable length per PA segment prior to laying the cables. If all these requirements are met, no system certificate is required for a PA segment. This saves much time and money for hazardous area applications. Various network components are required for setting up a Profibus DP and PA line. You can see here a small example application with Profibus DP and PA field devices. The PA field devices are placed in a Zone 1 hazardous area. For setting up the Profibus DP segment, you need sub-D plugs, DP cables, DP junctions, and a Profibus DP PA segment coupler to prepare for the Profibus PA segment. For the Profibus PA segment, you need field bus barriers, 2 types of PA cables, and PA sockets. The most commonly used components are available from ABB. Refer to the corresponding brackets for the ABB type designators. Now let's summarize this learning module. So, what have you learned so far? The number and distribution of bus subscribers and addresses per Profibus segment, which must not exceed a total of 32 subscribers per segment and 126 subscribers per line. The maximum length and transmission rate per Profibus DP segment, and that the DP cable length directly depends on the selected transmission rate. The maximum cable length and transmission rate per Profibus PA segment, and that the maximum PA cable length must always be calculated explicitly. The Profibus PA topology in hazardous areas, including the FISCO model, which considerably facilitates approvals for hazardous area applications. The network components required for a Profibus line, and the fact that ABB offers nearly all required components.